Hello, welcome to lesson 41. Yes, you will want to change this to lesson 41, where we will cover section 6.1 about multiple regression. So you are encouraged to read pages 261 to 266 in the textbook. So the principles of simple linear regression lay the foundation for more sophisticated regression methods used in a wide range of challenging settings. Multiple regression extends simple two-variable regression to the case that still has one response but many predictors. So these would be denoted x1, x2, x3, and so on. The method is motivated by scenarios where many variables may be simultaneously connected to an output. We will consider eBay auctions of a video game called Mario Kart for the Nintendo Wii. The outcome variable of interest is the total price of an auction, which is the highest bid plus the shipping cost. We will try to determine how total price is related to each characteristic in an auction while simultaneously controlling for other variables. For instance, all other characteristics held constant are longer auctions associated with higher or lower prices? And on average, how much more do buyers tend to pay for additional Wii wheels? These are the plastic steering wheels that attach to the Wii controller in auctions. Multiple regression will help us answer these other questions. The Mario Kart dataset includes results from 141 auctions. 4 observations from this dataset are shown in the table below. So each row represents a different auction. Descriptions for each variable are shown below. Notice that the condition and stock photo variables are indicator variables. These are variables that only have values of 1 or 0. So this is one way that we can deal with categorical variables. We can change them to numerical variables by just assigning a 1 or a 0 if they are there or not there. For instance, the condition new variable takes value 1 if the game is up for auction is the new and the condition new variable takes value 1 if the game that is up for auction is new, and it takes on a value of 0 if it is used. So using indicator variables in place of category names allows for these variables to be directly used in regression. Multiple regression also allows for categorical variables with many levels, though we do not have any such variables in this analysis, and we save these details for a second or third course in statistics. Let's fit a linear regression model with the game's condition as a predictor of auction price. The model may be written as prediction price equals 42.87 This would be considered the average price of a used game. Plus 10.90 times the condition new variable. The results of this model are shown below. So this number here, the 10.8996, is the additional amount you would pay on average for a new game. Okay, and up here I'll add another little detail. The reason why we know that 42.87 is the average price of a used game, that's because this is the y-intercept. And if the condition new is at a 0, that means that it's used. So 0, 42.87 would be the price of a used game. So this number would have to be a 1 in order for this price to be the price of a new game. So since it's 0, it's the price of a used game. This number down here is, if I added this price to my used game price, that would be the total price for purchasing a new game, right? So this is the additional amount you would have to pay on average for a new game. A scatter plot of the total auction price against the game's condition is shown, which takes value 1 when the game is new and 0 if the game is used. The least squares line is also shown. So let's ask some questions. Is this linear? Is this data linear? I mean, I don't know. I guess it's linear. I mean, we've got these vertical lines here, but they're kind of showing an upward trend maybe. So maybe we can say I guess it's linear. How about, does it satisfy normality conditions? Well, there seem to be a couple of outliers. Possibly. But they are not too far away. So I'm talking about maybe these here and these here. How about the constant variability condition? Pretty much yes. I mean, same amount of data on either side of the line. So, say pretty much yes. And then how about independence? Not sure. So we're not sure if this is collected in a time series or anything like that. So just not sure about independence. Here's example 1. So does the linear model seem reasonable? So after going through all of those conditions, again, we're not sure about independence, but we'll go with it. Anytime we want to run tests like this, we always want to be really transparent. So we would always want to make sure and tell the reader, whoever's looking at our data analysis, we would want to always explain the parts that we're not sure about, the parts that we said we're fine with, like if we're fine with these outliers, that they seem reasonable, they're not affecting it too much. We just want to explain all of that. Whenever we don't want to deceive anybody or trick anybody with our data, we just want to explain everything as transparently as possible. So example 2 says, interpret the coefficient for the game's condition in the model. Is this coefficient significantly different from 0? So let's write our hypotheses tests. So the null hypothesis would say that beta 1, which is this number here, equals 0, and the alternative hypothesis would say that beta 1 does not equal 0. So if you look at the second row here, which is the row that is the slope row, the beta 1 row, we can see that the p-value is pretty much 0. It's rounded to 0 anyway. So because this is less than 0.05, we would reject the null hypothesis. So this means that there is strong evidence that you will pay more for a new game than a used game. So we rejected the null hypothesis. Buying a game added an average of $10.90 to the price of the auction. There it is. So we have strong evidence that that's true.